We often need our application to make calculations that involve the values of certain attributes, constants, and/or functions. For these cases, GeneXus provides us with its formulas. We have two possible ways to define formulas. Global formulas, which are known in the whole knowledge base, and local formulas, which are known only in the object in which they were defined. Let's start by learning what a global formula is and how to define it. A global formula is a calculation we define in association with an attribute. We can see that the structures of transactions include a column under the title Formula. When we define a calculation for an attribute in this column, we're telling GeneXus that the attribute is virtual, meaning that it must not be created physically as a field in the associated table, because the value of the attribute will be obtained by doing the calculation we indicate. Let's exemplify this. We'll define a new attribute in the flight transaction to store the current discount applicable to each flight. We enter the attribute called flight, discount, percentage, and where its data type will be of a percentage domain we define now, as a numeric with a length of 3. And we define another attribute called flight final price, which we will define as a formula to automatically calculate the current flight price in this attribute. In the formula column, we define the calculation. Flight price times open parentheses 1 minus flight discount percentage divided by 100 close parentheses, and we press F5 to see what happens. We can see that only one field is created in the flight physical table, even when we defined two new attributes in the structure of the flight transaction. Because it has a definition in the formula column, this attribute is not added to the physical table. Because the attribute is defined in the knowledge base with an associated formula, GeneXus will know how to calculate its value, and the calculation will take place in all objects in which the attribute is present, with the results shown. Now let's reorganize. The programs have been generated, and here we see the application in runtime. We execute the flight transaction and query flight number 1, where on the transaction form we can see the two new attributes we defined: the discount percentage, enabled for us to enter it, and the final price, disabled because it is the attribute we defined as formula, and its value is not entered but rather calculated and then displayed. Every attribute defined as a global formula will be reading data, and we will not be able to type in any value for it. This is because the attribute gets its value from the associated calculation, which takes place every time the attribute is used. Also, there is no field in the physical table to store the value of this attribute, so making it editable would make no sense. So we enter a 10% discount for this flight. When we exit the field, we can see that the formula is immediately executed, showing the flight's final price with the discount applied. Now let's go back to GeneXus. So far, we've defined a global formula attribute. Only attributes may be defined as global formulas in the way we just described, and using the formula column in this transaction. Something important to bear in mind is that even when in the example calculation we included only attributes of the transaction itself, it is possible to also include attributes of the extended table. Let's see that. We create a transaction called airline to record the airlines. We define three attributes for it: airline ID, airline name, and airline discount percentage. From the percentage domain, to record the discount made by the airline for all its flights. We save, and now go to the flight transaction to assign to each flight the airline that operates it. We add the attribute airline ID, which here will play the role of foreign key, and change the value of its nullable property to yes. This allows us to not specify, in this first stage, the flight's airline, because we still don't have any airlines recorded. Further ahead, we'll come back to change the value of the nullable property to no, to make specifications of the airline mandatory when entering or modifying a flight. We add the attributes airline name and airline discount percentage to view this data on the form. We now modify the definition of our formula so that it calculates the flight's final price, applying to it the airline's generic discount instead of applying the flight's own discount. We then press F5. Now we see the proposal for creation of the airline physical table with the three attributes we defined, and for the foreign key, airline ID, to be added to the flight table. Now let's reorganize and execute. We open the airline transaction and add an airline called TAM with a 30% discount. Now to this airline, we will assign a flight. To flight number 1, we assign airline 1, and we will see that the flight's new final price has been calculated. As a global formula attribute, that includes the airline's discount percentage, which is an attribute of the extended table of the flight base table. One thing we haven't mentioned yet is that formulas can assess conditions and the result may be calculated in different ways, depending on whether such conditions are true or false. Let's see that. We click on this button with 3 dots to edit the formula more easily. We will define that the highest discount percentage be considered to calculate the flight's final price, so we get the best possible discount. We add if airline discount percentage is greater than or equal to flight discount percentage, and flight price times 1 minus flight discount percentage divided by 100 otherwise. With this definition, if the airline has a higher discount for all its flights than the flight's own discount percentage, for the calculation we will consider the airline discount. Otherwise, we use the flight's own discount percentage for the calculation. We then press F5. We execute the flight transaction, and to the first flight we will assign that its own discount percentage be greater than the airline's overall discount percentage. For example, 50%. We will see that the flight's final price was calculated upon considering the greater discount. Now let's get back to GeneXus. Formulas may contain several lines followed by if, and they might or might not contain a last line with the otherwise, for the case where none of the previous conditions apply. Also, even when in this example the way to obtain each result was through a calculation, we could also resort to functions applied to attributes or calculations such as round, to obtain a rounded result, or month to get the month from a date, among other options. And we can also call a procedure we have defined to return a value. We will now see another type of formulas which we will define also as global. We will create a second level in the flight transaction and call it seat. As the level's name indicates, we will use it to record the seats available on the flight, and we will record, for each seat, whether it's a window, aisle, or middle. Then we'll want to know, in all cases, the number of seats available on the flight. We type a period and fill in the attribute name, flight seat ID. We create another attribute called flight seat location and assign it to a location domain of the character 1 type. We now go to the domain node to modify a property in the domain we've just created. We find the enumValues property and define the three values the domain may have. Window, and the value that will be stored when window is selected will be the character W. Middle, where the value stored will be an M, and aisle, where the value stored will be an A. We then press OK and save the definitions we made in the flight transaction. Let's take a look at the form in this transaction. We can see that a grid was added to enter the flight seats, and for each seat, an indication can be made of its location through a combo control that provides the window, middle, or aisle values, which are possible values we defined for the domain of the flight seat location attribute. Prior to pressing F5, let's see something in the definition of the second level. If the key consists of flight ID plus flight seat ID, for each flight we will not be able to repeat seat numbers. But we need the possibility of repeated numbers plus a variable letter since, in general, seats are identified as 1A, 1B, and so on. So we add a flight seat chair attribute, whose type we define as a seat chair domain, with the character 1, and make the attribute part of the key to enable the record of equal seat numbers with a different letter. We will restrict the possible letters from A to F, and for that we edit the domain. We find its enumValues property and define the possible values. A, B, B, C, C, D, D, E, E, and F, F. In this case, the values of descriptions match the values stored. Now, in order to know the number of passengers allowed on the flight, we will define a new attribute in the first level as a formula, which will have the number of seats provided by the flight. We create the flight capacity attribute as numeric 4. And in the column formula, we write count and make a reference between parentheses to an attribute in the second level, such as flight seat location. And we close the parentheses. The attribute flight capacity will not be physically created in the flight table because it's a global formula, and it will always count the number of seats on the flight. We press F5. And we will see that the flight physical table seat is created, associated with the second level of the flight transaction with the attributes and key we have defined. The structure of the flight table will not be modified because the attribute flight capacity will not be physically created as expected. We agree, so we proceed. We execute the flight transaction, query flight number 1, and register some seats. 1A, window, 1B, middle, 1C, aisle, 1D, window, 1E, middle, 1F, aisle, 2A, window, and we leave it here. We should note that the seat count is updated every time that we add a seat to the flight. Let's go back to GeneXus. We also have other formulas of the count style that do operations with several records, such as sum, average, and others. The attribute reference between parentheses in the formula provides GeneXus with information on the table to be navigated for doing the calculation. If GeneXus detects a relation between the navigated table and the location where the formula attribute is defined, it will only take into account the related records for the calculation. In this example, where flight ID is present both where the formula is defined and where the navigation takes place, so only the seats of the flight we are in are counted, and not all the seats recorded on the table. If the relation is not found, then GeneXus will do the operation considering all the records in the navigated table. Also, we can count, add, or average certain records that fulfill an explicit condition we've indicated. By way of example, if we want to count the number of window seats on the flight, to the formula we add, inside the parentheses, a comma, and the corresponding condition. Because the flight seat location attribute is from the location domain, and it has these three enumerated values defined, the syntax to require the value that the attribute has taken is domain name, location, dot, and name associated with the value we want to filter. In this case, it's window. We press F5. We go to flight transaction, query flight number 1, and we see that the formula attribute was counted and now shows 3, which corresponds to the number of window seats, which matches the entries we made on the seat grid. Lastly, we must keep in mind that, just like all global formulas, these could also have a triggering condition. This means that we can add an if at the end of the definition with a specific assessment for the formula to be triggered only if that condition is true.